We're going to talk a little bit more about Jupiter, and one of the ways that we found out a lot about the planet Jupiter was from a probe that was launched in 1977 called Voyager. And there were actually two Voyagers. There was Voyager 1 and Voyager 2, and Voyager 2 actually was launched prior to Voyager 1. And this was the very first time that we had sent probes to the outer solar system. I remember being a kid through these years, and every time that Voyager would get close to a planet, it would take some beautiful, stunning pictures and send them back to Earth, and they would be published in National Geographic, etc. Fascinating and wonderful thing that was done. Now, the Voyager probe was also the first time that we sent something out of the solar system. After it was going to visit these outer planets, these probes were going to continue out into space. And so the idea was hatched to actually create a golden record. And the golden record, it was designed to communicate with extraterrestrial life. This is a picture that they actually etched into this solid gold plaque that was on the Voyager spacecraft. It has an image of a man and a woman, kind of a map, the sun, the Earth, and then the path of the Voyager spacecraft. This is supposed to represent our positions in the solar system, and also a little bit about binary code, ones and zeros, so that they could kind of understand our computer technology. On the golden record, it also had music. There was music, there was, 20, 30 songs that were included, everything from throat singing to Aboriginal music to Chuck Berry. And they included with the record, there is actually a little stylus so that if aliens ever find this probe someday, they can listen to the music. It was a wonderful attempt to throw a bottle in the ocean and see what would happen. Would anybody ever find it? Probably long after all of us are dead, someone might actually find this thing. Now, the Voyager spacecraft is actually the very first thing to have left our solar system. It was launched in 1977. It is still going strong today, and it has passed what is referred to as the heliopause. Pause means to stop. Helio means sun. So it is past the outer planets of Uranus, Neptune, and Pluto. It is past the Kuiper belt, and it is in this area where the solar wind has basically stopped. So officially, mankind is an interstellar traveler. We have actually sent probes out of our solar system. When the Voyager probes flew by the moons of Jupiter, it was the first time we got good pictures of these moons. As I mentioned, there are 60-some moons of Jupiter, but there are 4 that are important. These are called the 4 Galilean moons of Jupiter because Galileo first saw these with his telescope back in the 1600s. The 4 big moons of Jupiter are Io, Europa, Ganymede, and Callisto. All of Jupiter's moons are named for his lovers. And yes, there are over 60 moons, and they are all named for his lovers. Jupiter got around. The structure of the moons, each one's different. So they're kind of like extra planets that we get for no extra cost. Different layers of rock and ice and exteriors. You don't need to know all of this, but just please be aware of the fact that each one of these is very, very different from the others. We'll talk a little bit about these 4 big Galilean moons. The first one is Io. Io sort of looks like the surface of pizza. It has red areas and yellow areas and green areas where the peppers would be. It is the most volcanic body in the solar system. There's over 150 volcanoes erupting at any one time on Io. This was stunning. We did not know about any of this until we sent the Voyager probes out there. And then Voyager turned around and took pictures like this, and astronomers went nuts because they said, holy moly, what's going on? And this was actually a volcanic eruption on the moon Io. way out in the far reaches of the solar system. What causes Io to be so incredibly volcanically active? Well, it's tidal forces. Jupiter is a big gravitational beast. Io is this little tiny move that's near it, and due to equal and opposite forces of gravity, poor little Io is being pulled by the gravity of Jupiter. The front side of Io is being pulled by gravity a lot more than the back side of Io. And what that does is it takes this planet and is kind of attempting, the gravity of Jupiter is sort of pulling Io apart. Well, that pulling and squishing produces an awful lot of heat. And that heat causes volcanoes. This is another picture of Io, and those are infrared photographs. Those are hot spots, and those are actually those volcanoes. One of the other moons of Jupiter is Europa. Europa has the highest albedo of any moon that we know of. Very, very, very smooth surface. Well, about 4 billion years ago, there was a period of very heavy asteroid bombardment. And if you get a surface that looks like that, what that means is that surface is not 4 billion years old. It is constantly being resurfaced. Something is making Io get a new surface. What we believe is happening is, again, due to the gravitational tugs of big old Jupiter on Io. It is pulling and squishing poor little Io and keeping the layer underneath, the top layer of ice. But underneath this top layer of ice, there is actually a layer of liquid. And this layer of ice cracks, the liquid comes up, and it resurfaces the planet, sort of like a Zamboni will resurface an ice skating rink. It's really, really beautiful. You can see these pretty little ice crystals all over the surface, and you can see the cracks in the surface of Io. Ganymede. Ganymede is the largest moon in the solar system. It's actually larger than the planet Mercury. The surface is frozen water, plain old H2O water that we are used to, but it is very, very, very hard, and it is covered in dust. The dust that covers it makes it not white looking like a big iceberg, but it has this darkish gray covering to it because of dust on top of the surface. Rocky interior, like most other planets. And there are huge fault lines where there are actual earthquakes on Ganymede. And Ganymede itself has some sort of a magnetic field. It's kind of like a little baby planet, but it is a planet made mostly of frozen water. Oh, one of my past students said, Ganymede was named for Jupiter's cupbearer. And the cupbearer in ancient times was typically a male, not female. And remember I said Jupiter got around? He invented the idea of being pansexual. He didn't care. Callisto. Callisto is the outermost moon of the large moons of Jupiter. It has the oldest moon surface, so it does not get resurfaced. If you look at this, look at all those craters. Each one of these little light spots is a crater. Callisto is made of totally of ice, and then there's lots of dark dust on top of it. And when a crater would impact, then you would get these little bright impact craters. And if you look at this surface compared to something like Ganymede, this is much smoother, and you go back to Europa, very, very smooth. You can see a great, tremendous amount of difference between the surfaces due to resurfacing. There's a lot of liquid, and that liquid is going to resurface. By the time you get way out to Callisto, you don't have that resurfacing. You just have all of these huge craters. So this is no liquid is going to be found on that surface of Callisto. At least we don't think so at this moment. There's a massive impact crater on Callisto, and it has the name Valhalla. If you are familiar with the Thor movies and Norse mythology, that's where that name comes from. And it is a big, bright impact crater. And the nifty thing is, can you see the concentric rings? Really shattered all of the ice on that surface when it hit. Now, Jupiter has over 60 moons, and when you're done, I want you to watch this little video because it kind of gives you an idea of the other guys, all the other moons, where they are, and their relative sizes. Okay, that's going to finish Jupiter, and we'll come back and we'll talk about our good friend Saturn.